So the first thing is what you may not know about Seagate is that we are the world's #1 merchant supplier of flash controllers. We are the #2 supplier of PCI cards in the flash space. And we also have a SAS product line. That's what I manage. That's growing in many of our customers and partners are in the show today. We're also building the team out. Over the last few months, we've added several hundred people. We're now about a group of about 700 total worldwide that are focused in on flash products. And all of that IP that we're aiming at really is trying to get aligned towards what we see is kind of the key things to pay attention to for the next 3-4 years to be successful in flash. So number one is the geometries are getting smaller, right? And there's a benefit to the consumer of lower costs, higher capacity, higher unit volume, etc. But the challenge is it gets harder and harder to store those bits in an effective way. And you have to deal with more error correction along the way. So one of the things we've learned as a hard drive company is that we learned how to manage imperfect media, and flash is no different. Flash is just another imperfect media. So the challenge here is to manage it with media that's getting harder and harder to deal with, shorter endurance, lower reliability, putting more ECC coverage on it, but yet maintaining enterprise level kind of performance pieces. So that's where we've invested our IP, and our energy is into building the controllers and the firmware and software that manage that flash. And as we think about flash being used not only in high performance computing but in hyperscale as well, we see a handful of trends also occurring that need to be paid attention to from an interface perspective. The first of all is, the three general interfaces that are being used for flash products are SATA, SAS, and PCI. And all of them are, good technologies, but what we see is that SATA, from an interface perspective, is really reaching the limits of it. We can saturate a 6 gig link with flash quite easily. And the whole point of flash is to go faster. So at some point, SATA is just not going to be able to be pushed any further. And really, when you're thinking about supercomputing kind of performance levels and whatnot, you're going to need to think about moving to SAS or PCI. Now, both have benefit. SAS in the respect that, and we'll get into it in just a little bit here, but both are fast, but both have kind of different use cases. And then the right side of the screen is all about the media itself has a certain performance level. And what I wanted to kind of communicate on this point is that both SAS and PCI are fast enough where we're faster than the media. We're actually waiting on the media, and now it's about our intelligent controller designs that allow us to kind of get to higher performance levels. So we use things like SRAM for buffers before we move it to the flash, etc. We protect the data in flight, all of those things to reach higher performance levels. So here's a quick overview of the product portfolio. We've got samples over here on the side as well. But we've got a 12 gig SAS product that is externally known as the 1200 SAS. It is designed for traditional storage systems, so dual port, high availability, high failover, high endurance levels, etc. Probably for your most difficult workloads that are designed. Then we have the Nitro line. Again, this is a brand new product line to Seagate as of September. It came over from an acquisition of LSI and Avago assets and whatnot. And this card is the #2 supplier of flash PCI out in the marketplace today. Incredibly fast, gaining mind share and support in hyperscale accounts. A number of our potential customers are here at the show as well, but uses the PCI card accelerator, right? So puts in a PCI slot, runs server side, and is a kind of a third generation using existing device drivers. That's the other benefit to it is that it is based on great technology that has been matured over quite a bit of time. A little hint to the future here is a mid-range, something we're calling the mid-range PCI. So it's a blend of what you're seeing with SAS and PCI. In the next 12 months, what you will see is PCI drives that are using a form factor that looks like a drive, but the interface is PCI. It'll have a by 4 lanes, so 4 lanes of PCI coming out of it for very high performance levels and getting you the advantages of latency. Now, what the industry is working on right now, this is why it's a next year kind of thing, is building the backplanes that support PCI. You know that SAS is technology that you're able to do hot swap and unplugging and some of the things that seem kind of pedestrian at this point. PCI is meant to be plugged into the PCI bus, and when you take something out of that bus, really it creates a panic if the bus is still has power on it, etc. And so that's what the developers and whatnot and the industry, including Seagate, is working on, is how do we make PCI hot swap? And now you'll get kind of the benefits of both. That's coming. Probably next summer you'll see some of the first examples of that. There are a few technology demonstrations that you might see right now. So let's take just a little quick view of each one of these things. So again, sorry about that. On a SAS product line, 12 gigabit using 2 ports really gives you 24 gigabit of aggregate performance. That's an incredible amount of performance. There's only a handful of applications that I'm aware of. If you use multiple SAS SSDs, will actually even be able to absorb that kind of performance levels. And what the great benefit of a drive is, you can scale it, right? So if you need 4 drives or 8 drives of performance or capacity, it's a very scalable building block for your systems and whatnot. All of our customers are using them in applications of virtualization. Sorry about that. I don't know where this is coming from, so I'll try and find the spot that doesn't do that. Databases, and what's really happening here is a trend in software-defined storage. For many years, when you wanted storage, you had to go to a company, one of the big 5 that had big storage systems and whatnot. Now with things like vSAN, Microsoft Hyper-V, Nexenta, a number of different companies in this space, you can take a commodity server, combine it with drives, and do an incredible performance level of storage, a storage system, all with common building blocks. That offers a lot of flexibility to you. It lowers the cost of storage in the industry, etc., and gives you more flexibility and options. From a trend in the industry that we see as significant, it's the movement to software-defined storage. Just a real quick thing, I think SAS, again, just a high level here is that if you add up all the 12 gig links as dual port, full active, and full duplex, if you add all of those things, SAS has the capability of doing 48 gigabits per second. But what it's really known for is being able to deal with multiple hosts. And again, in a HPC environment where this is the case where you've got thousands of processors who are trying to access, SAS is a great fit for these kinds of environments because the design itself is meant for multi-use. This is what we are working on to add to PCI so that PCI can be used in similar ways into the future. And then we do extensive amount of interoperability. Again, we have lots of partners in the industry and whatnot. We want to make sure our products play nicely with everybody. So part of the process is making sure that we've already kind of qualified it that way. When you as a customer are trying to deploy it and whatnot, you have a high degree of confidence that we've already tested it for you. Now I'll move on to the Nitro line. Again, this is the new PCI cards that are being added to the marketplace. And really they have 3 different categories of product because there is no one environment that matches everybody's needs. So the first one is something called a warp drive, where you can aggregate devices directly attached to that. And that's for people who want the ability to have hot swap removable storage, as well as being able to add capacity to the PCI card itself. Remember what we talked about, where PCI itself, you can't unplug it from the bus without creating a panic on the processor itself without powering down and whatnot. Warp drive solves that by putting little modules on each of the drives and whatnot. The next one is the Nitro 6209. It's really designed for thermally optimized environments. Again, when you get into some pretty high density environments, you don't necessarily have the same power and cooling envelopes and whatnot, and so this design has been optimized to fit into kind of the lowest thermal envelopes, but yet providing great performance. And then if you don't have that constraint and you're looking for raw power, that's the 6302, right? That's our highest performing product in the portfolio, and it does have the artifact of needing more power in order to get to those same performance levels and whatnot. But you can get capacities all the way up to 3.2 terabytes in a single flash card. So when I think about what flash does to computing today, is it increases the access density of storage. It's an incredible amount of IOPS in a very small footprint. And now you have to think about a couple of other metrics. One is how much power you can deliver to the environment. And then the other thing about flash is being able to manage its life. So where Seagate is trying to differentiate ourselves is providing a full portfolio of products based on different kinds of workloads, and we'll talk about that in a little bit. So Nitro is used in similar applications to SAS. SAS, again, is a nice building block if you want to scale performance and capacity in a kind of device-by-device basis. That's what it offers you. Nitro is nope, I know exactly what I want to put it into a PCI card slot. I know that 3.2 terabytes will be sufficient, etc. And it's really in an environment where the server itself is the FRU, not the storage device. So very similar applications to what the SAS is. There's where you would make the differences. Do I need scalability and removability? Then I'd use SAS. If I want highest performance and my server is the FRU, then PCI is a great fit for you. And just a little closer zoom in to the 6302. It's on display over here, but incredible performance levels. 3.9 gigabytes per second is the performance rate that we can do on reads. 4 terabytes raw capacity, so you're really getting a tremendous amount of performance per footprint out of a PCI card. And what differentiates this product over others that are in the marketplace is the low CPU memory burden. So competitors use onboarding of a lot of the flash translation layer onto the host CPU resources in order to get their performance levels up. That has an artifact that it consumes some of the CPU resources and memory that would be needed for an application. So be careful about those kinds of things. This one is a completely off-board design where everything you need to reach these performance levels is on the PCI card itself. So the last few slides here I'll talk about is how flash is being used in Seagate's portfolio. So the cluster store team here has a number of products, including the Cluster Store 9000. For the Cluster Store team, we've been working with them way before they became part of Seagate, and for them to be able to achieve the performance levels that they are able to on the 9000, it was only enabled by using flash in their architecture. And really it was a pair of mirrored SSDs. It doesn't take much, but it's really used for high IOP performance on the journals themselves and small block updates. And by boosting performance in this area, I think they got a 3x fold performance improvement over the last generation and whatnot. But talk with my Cluster Store teammates to get the exact number if you're curious. And then, of course, this is important stuff. So every design has power loss data protection. In the unlikely event you lose power, the data itself, metadata, and all the journal updates have been protected. The other exciting part about the portfolio is how Seagate is expanding the opportunity for our customers. Not only can you buy our devices, hard drives, SSDs, PCI cards, we now have chassis that you can integrate all of those devices into, and making the combinations that are right for your environment. So we've really, this is the last 9 months have been the most exciting about finding customers with different unique sets and having this flexibility to be able to design something just for them. What's unique about this is because we make the devices itself, we can do a much deeper level of integration testing so that when you get it at the system level, it's already been pre-tested and you load the software onto it that meets your application. So the next step is doing reference designs with companies like CleverSafe, etc. So that, again, you've got all the building blocks necessary for your storage. Just to give you one example of a combination of those things is the new chassis that my teammates have introduced is a 12 gigabit SAS chassis. It has 24 ports coming out from the host, and when I combine that, I'm almost at 30 gigabytes of aggregate performance out of a 2U box. That's an incredible performance level. I don't know of any kind of design point that can reach that kind of performance density, and it's just using SAS, but the 24 ports is really what enabled it. Now our drives this generation aren't able to fully saturate that 12 gig link by next summer. We'll be able to actually hit that theoretical limit. Now, where could you use applications like that? Many of the applications you see here at the show are the ones that are pushing the envelope of how much performance that I can get in the smallest footprint. Visualization is a key one, but any kind of scratch disk for computational temporary files, etc., they all need to burst to a high performance storage pool, then bleed it off to other storage and whatnot. So there's where it would be a great fit for this kind of technology. And the worlds of HPC and hyperscale often kind of combine. We're demonstrating, one of my colleagues here was talking about putting Hadoop on Lustre. And so you're seeing the combinations of different technologies that maybe perhaps were disparate and whatnot are now combining together. And so a lot of what I just shared with you is we get a lot of feedback from the hyperscale groups as well about how to design our products. But one thing kind of comes in as a general theme here is that they want more performance in a smaller power envelope, and flash is the technology that's leading in that direction. So why Seagate is interested and why Seagate is very excited about doing that. So with that, I'd like to thank you for your time, and I think there is a drawing here, if I remember right.